Thank you for the introduction. Thanks, everyone, for the opportunity for being here. Let's together explore the image sensor world, this tiny device behind any vision-based application that we see. So a glimpse through this fast growing kind of, so vision-based application around us, which have impact, direct or indirect, in our lives, positive, hopefully, and sometimes negative. From a smartphone, security camera, facial recognition in security cameras, autonomous driving, field training with the AR goggles, drone monitoring for crops, robots in the warehouse, and driver monitoring. They're all using image sensors, and their performance hinges heavily on the underlying technologies, hardware, computing, and sensor, and let's say AI. So the success of any AI model definitely hinges heavily on the input data that is provided to the AI model. Precision and efficiency are the keys for certain application. Precision is the key, very crucial for applications such as facial recognition, driver monitoring, and also efficiency, especially in the edge AI application, is key in order to capture the data efficiently and processing the data efficiently. Image sensors, good quality image sensors provide better data. As a result, you will have a very reliable and accurate output with your AI model. So that's why that we are having this talk today. So how image sensor works is the topic of this presentation. We go over some of the key terminologies that you encounter in the vendor meetings or in the data sheet from the sensor vendors. And we are trying to tie these performance metrics with your application requirements. What are the considerations? What are the trade-offs that you need to have with your application, vision-based application? And let's say they're achieving optimal performance in your edge AR or AI-enhanced solution depends on choosing the right sensor underlying hardware of your product.